problem number 3 on page 176. So again, just like with all the force problems, first thing you have to do is draw the situation. So we've got this car, we're given its mass, we're given the angle of the hill. What we'd like to know is actually the length of the driveway, which, in other words, we're asked for delta x. We're looking for the displacement that the object undergoes. Okay, now with that, I'm going to erase that so it doesn't get in the way, because you know what we're going to do next? Going back to a force diagram. We're given a bunch of forces. There's a lot of other information we're not given, so we want to draw the forces in there. Okay, so we have F sub g. We can figure out Fn. I'm not even sure we're going to need it yet. We have the force of friction, and this would be kinetic friction, of course. So actually I should put F sub k. That's a given. And we have VI car, and we have VF car. Do we not? What's VI car? What's VI car? Read the problem. What is it? Okay, hold up fingers. What is it? 0! 0 meters per second, starting from rest. The F car is given as 3.8 meters per second. Okay, so we've got mass, we've got VI, we've got VF. We're looking for displacement. So let's toss out a couple of equations. The work done will be equal to 1/2 mvf squared minus 1/2 mvi squared. This is true, right? That doesn't give us displacement. The work done will be equal to the force times the cosine of theta times the delta x. Okay, which gets us force, but it doesn't get us anything to do with mass or velocity. But we have everything that we can, we've got everything we need here. This is equal to work. We've got the cosine of theta, we want this, and we can figure out the net force, because this is net force. So we now have two things that we can set equal, yes? Okay, so let's do that. 1/2 mvf squared minus 1/2 mvi squared equals net force cosine theta delta x. Are you starting to see something you can work with here? Yeah? Okay. So let's rearrange to solve for that. So now we're going to have mvf squared minus mvi squared over 2 f net cosine theta gives us the length of the driveway. Do you follow the algebra there? I rather than having these multiplied by 1/2, I just moved the 2 to the denominator. Okay. At this point, what do you have to do to compute net force? Well, is there a force applied? What's countering that force of kinetic friction? Let me get another colored marker. And I have what?
Everything but F net, right?
Well, we're not given F net. We have to compute F net.
That's I know, but that's most things.
Oh, yeah. In here, you have everything you need except F net. Right. So I'm not going to finish this problem for you. But if we break down our gravitational force, we have F of g on the y. Well, we know that's got to be equal to normal force, and quite frankly, we don't care. We also have F of g on the x, right? There's our other force on the x-axis. We know that our net force is going to be on the x-axis. We know that F net will equal F of gx minus F of k. Yes? Or actually, I guess, well, it's probably not going to matter in this case which is negative and positive. But that's going to be our F net. Make sense? So again, in terms of problem-solving strategies with these, toss out all the equations that you know that could potentially relate to this. Draw the situation well. Write down all the variables you've got. Toss out all the equations that you've got that could potentially relate to the situation. See what you can set equal to other things. So now you're at a point you guys can all solve this on your own, yes? Okay. Other questions on 5C stuff?
I have a question on this.
Yeah.
How do you get the second equation for work, F cosine?
That's the first equation that we learned in this chapter.
All right.
So work is equal to, work equals FD, but we more commonly actually say that work is equal to F delta X. But since we know that if we have a box here and we're applying a force this way, we're pulling on a leash.
Yeah.
The only part of your applied force that's doing the work is the piece that is in the same direction as the motion.
All right, and that's just cosine.
And that's, yeah. And what I had said, though, is your book states that universally that is cosine theta. What I'm going to tell you is that 95% of the time it's cosine theta. But always look at your situation, always draw your picture. There can certainly be an instance, especially like if you're shoving something up a wall or lowering something down a wall, there could be instances where the applied force that's in the same direction as the motion will be given by sine theta. So just be careful. It's almost always cosine, and especially since we're doing the easier problems out of the book, this is more a reminder for when you go on to college physics. When you're doing these kind of problems, look at the situation. I'm never comfortable assuming that it's going to be cosine because then you can get fooled. Other questions on this? Pardon?
So let's see if I can see any sign of this one. Just to have a personality mix.
No. Because the net force here. Okay, so that's a good question. That's a good question. What is the theta that we're concerned with here? So theta here is the angle between the net force and the motion of the object. So what's theta here? You have two options. Well, you have infinite options, but there are two really obvious ones. One is 20. That would be wrong. Where's the net force in this case? It's right down the driveway, isn't it? Because here's, if we transpose this f of gx up here, we know f of gx has got to be bigger than f of k, or the vehicle wouldn't move. So our net force is along the surface of the driveway. Our motion is along the surface of the driveway. What's the angle between the net force and the motion? Zero. It's zero. Because here's where our net force is going to be. Here's where our motion is going to be. There's no angle between them. So that's cosine of 0. Make sense? Now this is doing the whole tilted axis thing that we've been doing since chapter 4 to have our force of gravity be right along the driveway. It's almost the only way to handle those. Other questions on this? You guys have good questions? No? Okay, I'll stop the video on this one. I'll actually give you time to solve this and check your work.